Welcome to a series of episodes, I'm thinking maybe 3 parts, where we're going to talk about an engineering concept called control systems, also referred to as feedback loops. But actually, it's not just an engineering concept. Really, it's a way to describe things in life where you are starting wherever you are. You have a goal, you're trying to get there, and how do you make sure you get to that point? So I realize that if you're watching this video, you may or may not have seen previous videos. So I'm going to go over concepts that may be repetitive if you've been watching a lot of these videos, but I want to make sure everybody is on the same page. So when we think about design, design is going to have a lot of different connotations in people's minds depending on their background. But a very simple definition is design. It's the courses of action that allow you to move from existing states to preferred states. And this definition that I just said is by the late Professor Herbert Simon. He's a Nobel Prize winner in economics and pioneered a lot of the theory and the application of economics and game theory and artificial intelligence. And that's sort of his general definition. You can also think of it as wherever you are currently and how do you get to your desired location. You can also think of it as where you are now and where you want to be later on. And this arrow is your plan and design. And if you've ever done any sort of project where you've set out to do something and then you do it, you know that it is never a straightforward arrow. Often your goal changes. And talking about design, you can learn a lot more about that in other episodes. But with that framework in mind, I'm going to talk about control systems and feedback loops. And what we want to keep in mind is you're trying to regulate or maintain some sort of thing. We call it a variable. And I'm going to give you some examples later in this episode so that will be made a lot clearer for you. You got your plan, you got your design, and the key thing is how do you know that you've got there? Are we there yet? So you have some sort of goal that you want to get to. Maybe you're designing a robot. Maybe it's like a New Year's resolution, some sort of goal you're setting for yourself. So how do you define that goal? What are you going to do to get there? How will we know when we've achieved it? And then do we need to adjust some of this activity? Another way to summarize it here is you're going to act, measure, and then adjust. And you could add more things such as planning beforehand and also anticipating for things that expecting the unexpected. All right, now one related concept is this concept of homeostasis. This is the Wikipedia definition. It's the state of steady internal and chemical conditions maintained by living systems. And so this term, actually steady state, that's a term that is used in control systems. And then maintained is another key word. So let's take a look, visual way to see what we're talking about, 2 different ways, and then we're going to finish up with some examples. So if we just look at the first row, think of this as different pictures of a comic or different scenes. And we have a seesaw here. Now hopefully you don't get too caught in the details, all right? My lines aren't perfectly straight. The fulcrum, the middle, the pivot is not going to be exactly in the middle. But imagine in the first step, you have your seesaw balance, and that is your goal. In the next goal, it is tipping over to the other side. So in order to get back to your original state, you're going to apply some sort of force. All right, that's what this dotted arrow is on the right. Now, once you apply that force, however, you may realize that you've tipped it over too much to the other side. And so you would want to act in a way that's opposite of what you did in the previous scene. And then you get to the final step, which is basically what you had at the beginning. Another way you can think of it is a number line. All right, we could be measuring any number of things. And let's say 0 represents there is no difference between your current state and your desired state. That kind of sounds by definition, but we have to say it in that way. What you want is what you have. So there's no difference. Now, let's say in this number line, whatever it's measuring, it's all the way to the left. And conventionally, usually to the left is too little, and then to the right is too much. But let's just say it's off balance. So then in step 3, you want to do some sort of action that's going to cause it, and again I have this dotted arrow here, to move back towards the middle. Okay? And then in step 4, you realize that you overshot, you overcompensated. So you're going to go back the other way. Right? And then you are back, you find yourself back in the middle. Now, with this sort of framework in mind, let's think about what are things that need to be maintained. And so feel free to pause this video at any point before I say the answer if you want to think about it yourself or look things up. When I looked this definition up in Wikipedia, there were a couple of things that come to mind. Maybe they come to your mind. So we have body temperature. Body temperature. All right, and we know that if it's too hot, then we will sweat. It's our body's way to try to cool off through evaporative cooling. If it's too cold, then we will naturally shiver. Right? That shivering is trying to warm us back up. If you think about, and I'm not going to get into the physiology of it, but sort of nutrients and various other measures within your body, we know that if our body needs energy and nutrients, then we will be hungry. And if it is in need of hydration, we're going to be thirsty. Those are going to be the actions to get us to our balance point, our homeostasis. Now, I'm going to talk about a few more things that aren't specific to homeostasis that will sort of lead us into the second episode. Pause for a moment. What other sorts of things might we want to control? All right, what might we want to maintain that are sort of everyday occurrences? So pause the video and come back. There are a number of things. So we have temperature again, but in the kitchen we find two very common things. We have the oven, and then we have the refrigerator. So with the oven, you might know that when you are cooking, baking something, you want to preheat it. Make sure you get to that proper temperature. You know that the refrigerator is going to cycle on and off. Right? There's something measuring it inside to make sure that it maintains the proper temperature for either the refrigeration portion or the freezer portion. If we think about cooking, right, that's sort of related to temperature, there when you are baking, let's say, or cooking, right, you see how done is it? And the question, or I guess part of learning how to properly cook and bake and all, is that are the actions reversible? So if you think about baking something or overcooking something, a lot of times it's going to be hard to undo. And that's unfortunate, but that's part of learning. Whereas a lot of the other things that you're maintaining, they naturally go back and forth. So whether with our seesaw example, sort of pivoting back and forth, got my pen here, or with the number line example, it's going to go back and forth. Another very common example is speed, and specifically the speed of a car. All right, so when we're talking about driving, we've got the speed limit and other factors that will sort of dictate how fast we drive and how much in a rush are we going. Another example used in control systems is filling a cup of water. So the way to illustrate this would be to have one person tell the other person to pour a cup of water, all right? But the person pouring the cup, they're only going to listen to the person giving instructions. So you can imagine initially when you pour the cup, all right, it's going to be like, okay, turn over, right, a certain amount. But as you get closer, you sort of loosen up, or you pour less until you get to the right amount. And you can imagine if you over pour, then you might need to pour out some of the water. So just trying to give you a bunch of different examples. And then normally what is not thought of in control systems engineering, but I think it is very much so, ways to understand this. If you think about in the, let's say, school setting or as a parent, you hope to instill certain behaviors or values in children. And so you might need to say, hey, where the person is at is not where you want it to be. So what sort of actions, interventions might you use to help that person get to that point? As students, worried about grades a lot, Of course, the focus is never purely on the grades, but you want to know how you're doing in a class. And so tests and feedback, that's going to help you adjust what you're doing so you can get to that stated goal. If you think about health goals, all right, if you're trying to maintain a certain weight, or I know wrestlers and fighters, sometimes they are in certain weight classes, so they have to eat and then see how their weight responds. Or let's say if you are trying to get stronger, all right, you want to see if the conditioning and the training you're doing is getting you to your goal. So we're right past the 10-minute mark. I think I've covered the concepts that I wanted to cover, and so we'll have maybe 2 more episodes where we'll dive in a bit to the engineering, how at least in engineering this sort of concepts are modeled, and then this could give you a more formal understanding. And also, if you are trying to apply some of these concepts, especially in our engineering, robotics environments and contexts, hopefully this will give you a good framework. Thanks for listening, and we'll see you next time.